Welcome to qnawire.
Our question says that we have a ball which weighs 0.550 kilograms. I write that as mass M. And it falls directly down onto concrete. And it hits it with the speed of 12.0 meters per second. So V of 0 is 12.0 meters per second. And that is in the negative j hat direction, okay? And is rebounding directly upwards with a speed, which I call V final, of 3 meters per second in the positive j hat direction. So extend the y-axis upwards in unit vector notation, which I have written here. What are A, the changes in the ball's momentum, B, the impulse on the ball, and C, the impulse on the concrete? Again, all in vector notation. So for part A, the change in momentum, delta P, is equal to the initial momentum, or excuse me, the final momentum minus the initial momentum. Well, the mass is the same in both cases. So we'll pull that out front. So we're going to have the final momentum, V of F, which is a vector. Forgot to write that up here. Minus the initial momentum, V of 0. And remember that V of 0 is in the negative j hat direction. So negative minus a minus becomes a positive there. So this comes out to be 8.25. Units here are kilograms times meters per second since it's momentum. And this is in the positive j hat direction. So we can box that in as our solution to part A. Now for part B, we're asked to find the impulse, but from the impulse momentum theorem, the impulse J is going to be equal to delta P. Therefore, the impulse is also equal to 8.25 kilograms times meters per second, but kilograms times meters per second is the same as newtons times seconds. So we'll just write it as Newton second because that's the common units for impulse. And we can box that in as our solution for part B. Now part C, it wants to know the impulse of the, since that was the impulse on the ball, it wants to know the impulse on the concrete. But from Newton's third law, where every action has an equal and opposite reaction, the impulse on the concrete, we'll call that J sub C. Rewrite that here. J sub C is going to be minus the impulse on the ball. So negative J sub B, which is what we found in part B. So this has to be minus 8.25 Newton seconds in the j hat direction, or 8.25 Newton seconds in the minus j hat direction, however you would prefer to write it. But we're going to box that in as our solution to part C.